exponential equations. Now in grade 10 and 11, we did the easy ones. 2 to the power of x equals 8. Then you have to prime factorize 8. When the bases are the same, the exponents are the same. Now in grade 12, we say 2 to the power of x is 9. If you prime factorize 9, you'll get 2 to the power of x equals 3 squared. Therefore, what is x? The bases are not the same. What do you do then? Logarithms. Okay, let's look at a few examples. The first one is 2 to the power of x equals 3. Now, I'm going to show you two ways to do this. The first one is you write log on both sides. Remember, if you do something on one side, you must do the same thing on the other side. So I can put in logs. Then I apply the rule where you have log something to the power of something. Then that exponent goes and stands in front of the log. Now I want to solve x. Therefore, I divide with log 2 on both sides. Then x is alone. It's log 3 divided by log 2. This you type in on your calculator. Block over block, log 3 on top, log 2 at the bottom, and then you get a long decimal number. Now, depending on the question and the instructions, you have to round it off. In this case, 3 decimals. So you look at the fourth decimal, it's a 9. It changes the 4 to a 5. Therefore, it's 1,585. Are there any questions? You are going to use it in solving x as exponents. You're going to use it in determining the number of years in finances.
Yeah, I mean, why would you in which situation is this logarithm like when we multiply log on both sides instead of just saying log log base 2?
Okay. You can choose which solution you would like.
But don't they?
Okay, the other solution is you use the definition of log. That's what you say. Yes. So this is the shorter version. But I want you to know that you can put in logs on both sides and solve it this way as well. The other one is, the other solution is, you apply the definition of logs. Log base 2 of 3 equals the exponent. And then you type that into your calculator, you get your long decimal number, and then you round off. This is a shorter way to do it. You can choose both ways. Okay. Our next example, solve x. Now x is an expression in an exponent form. What are we going to do first? Don't look at your notes. Look here. Divide by 25, then we get 12. And then you can put logs on both sides. Then you take the exponent to the front. Yes. Divide by the log 1 comma. And now you take the 7 to the other side. Get your answer. In this case, when we have an expression as part of your variable that you have to solve, I would do this way, the log way. instead of going the short way, because now you have x plus 7 on one side. Okay. But let's do it. Other one, by using the logarithm definition. First divide by 25, then put log, use the definition, so log of this base of 12 equals the exponent. Get the x alone, take the 7 over to the other side, type it in, round it off. Okay. Example 3. You can use logs in finances, you can use logs in numbers and sequences, series and sequences. So this is an example of number patterns. Calculate the biggest value for n for which the sum of n terms will be less than 2000. Now you can remember when we do this less than sums, we actually equate it to 2000 and then at the end you apply your logic. Okay. First you need to identify which series it is. It's a geometrical series. Therefore I have a ratio of 2. My first term a is 5. The geometrical series sum formula is that. Now you substitute a and r and Sn. 2 minus 1 is 1, so if you divide by 1, you only get the equation. I'm going to divide by 5, both sides. Then take over the minus 1. And now I'm stuck. I can't prime factorize for a 1. So you either apply the log definition or you put in logs on both sides. If you put in logs on both sides, you take this exponent to the front. It's the log law number 3. Then divide by log 2 to get n alone. Type this in and then you must apply your logic. The sum must be less than 2000. So if the sum is equal to 2000, I get n as 8,6. So what must n be if it's less than 2000? 8. If you do it this way, applying the definition, so the exponent equals the log of the base of 401. Type that in, get your decimal answer, and then apply your logic. Right, are there any questions? This is actually very easy. You can do it either by putting in 2 logs, or you can solve your answer by applying the definition. Your homework for tomorrow is exercise 6, page 25, number 1A to E and 2A to C. Don't start on it now. I want to mark last week's.